now we've looked at matter, we've looked at measurement. Finally, we're going to look at uncertainty in measurement, and this is probably going to be the most important part of this entire chapter because you're going to use it time after time after time again. So as we look at uncertainty in measurement, there's a couple different things to think about. Exact numbers versus inexact numbers. So exact numbers are counted or given by definition. For example, you could say there are 12 eggs in 1 dozen. Right? So a conversion factor is an exact number. Inexact numbers are numbers that we measure. Okay? It depends on how we determine it. Scientific instruments have limitations. Okay? Some balances measure to, 1/100th of a gram. Some measure to 1,000th of a gram. And so it's important that we record our measurements in the most precise way as possible. Which brings us to the first part of uncertainty. It's accuracy versus precision. Accuracy refers to how close our measurement is to the true value. Okay, if we're trying to determine the boiling point of water, how close are we to 100 degrees Celsius? That's accuracy. Precision is how close all of our measurements are to each other. Okay, so if I'm trying to find the boiling point of water and I get to 90 degrees Celsius every single time, I might not necessarily be accurate, but at least I'm precise. And these dartboards on the side give you an idea for what it would look like to be accurate, precise, or just one or the other, or neither. So as we go through accuracy and precision, as you work through labs, I might ask you to determine percent error. Percent error shows you how accurate you are. Okay, how close were you to the actual value? So percent error is the absolute value of the observed minus the accepted divided by the accepted. So this is what you found in lab, right? Experimental minus actual divided by actual is another way that you'll see it. And then since it's percent, you want to multiply by 100. So I talked before that different pieces of lab equipment have different degrees of accuracy. So graduated cylinder, syringe, a burette, these can all give variable volumes, right? The volume varies. You can fill it up to 91, you can fill it up to 45.5, they all depend. A pipette, okay, and you may have not worked with pipettes very often, this is a pipette. It delivers a specific volume. So if we need to deliver exactly 1 milliliter, a lot of times we're going to use these pipettes. Or you can use a volumetric flask, which contains a specific volume. So we use these volumetric flasks when we're making solutions. If we need exactly 1 liter of solution, we use a volumetric flask. So now we get to the important part, significant figures. If you look on the class website, I have also posted the notes on just significant figures. So if you want to download that and look through that as well, that's going to be a very good resource. The term significant figures refers to digits that were measured, right, including an estimated measurement. When we round numbers that are calculated, we use significant figures so that we state our answers to the most precise or the most accurate way possible. From now on, all answers must use significant figures correctly. Okay, you cannot give me an answer that has 5 significant figures when you're given only had 1. Okay, so significant figures is going to become very important. Rules for AP Sig Figs. Okay, never round until you get to the answer. You can leave it in your calculator if you want. You can write it out to 5 or 6 significant figures, but never round until you get to the answer. Always round your answer to the correct number of significant figures. If you use that answer, right, let's say you calculated something, if you use that for another calculation, use the unrounded version. Okay, this is going to be a very important step. Always use unrounded versions in calculations. Do not round until the very end. And then if all else fails and you're not sure, usually about 90% of the time using 3 significant figures will work. because on the AP Chemistry rubric, when they grade you on the exam, usually they allow plus or minus one significant figure in your answer. So, a review of significant figures. Again, you have a 2-page significant figures notes on the class website, so if you want to look at that as well, you can. But the rules for significant figures, all non-zero digits, 1 through 9, are significant. Zeros between two significant figures are also significant. So these are called captive zeros. Okay, captive zeros are always significant. Zeros at the beginning are never significant. So 0.00001, okay, all of these are not significant. They're just placeholders. And then zeros at the end of the number are significant if there is a decimal point. Okay, so if there's a decimal point, so 1.00, these are significant. In 100, there's no decimal, so it's not significant. Okay, this is going to be extremely important. So, since significant figures are so important, we're going to do some practice. What I recommend you do is pause the video, try these on your own, and then look back and go through any that maybe you had trouble on. So, how many significant figures are in the following? Okay, well, this 4 and this 3 are significant. The zeros in between are captive, right? Any captive zeros are always significant, so this is 4. We have Avogadro's number, 6.023. Okay, only look at the number in front of the times 10. Okay, any of this that comes after, not significant. Only the ones before the times sign. So again, this is 4. Captive zeros are significant. In the third one, we have 5,000. Okay, so this 5 is significant, but because these trailing zeros don't have a decimal place, they're not significant, so it's just 1. The next one, we have a decimal, so that is 3. And then same thing in the last one. We have a decimal. Remember, ignore the times 10. So that's 2. So looking at significant figures in calculated results. So when you're adding or subtracting, you always want to round your answer to the least significant decimal place. Okay, so addition, subtraction, go to decimal places. Okay, multiplication or division, go to the least number of significant figures. So here are just some examples of looking at the addition and subtraction. Okay, notice here you only have one decimal, so you go to the least number of decimals. Looking at the second example, we don't have any decimals, so we just give our answer with no decimal places. Looking at the multiplying and dividing, remember we go to least number of Sig Figs. This one we have 1, 2, 3, 4, 5, 6. This we have 2. So our answer needs to be given in 2 significant figures. Okay, remember, leading zeros are never significant. In this second example, we have 1, 2, 3, 4, 5. And in this bottom one, we have 4. So our answer needs to be given in 4 significant figures. So now we have 2 examples coming up. Again, what I would recommend doing, go through this, see if you have questions, pause the video, and then once you go through the problems on your own, resume the video, check answers, see if you have any questions or anything. Alright, so looking at this example, we're finding the volume. Volume is length times width times height. I multiplied 27.3 times 15.5 times 5.4, and I got 2,285.01. However, we are multiplying. So because we are multiplying, we need to go to the least number of significant figures. 27.3 has 3 sig figs. 15.5, 3 sig figs. 5.4 has 2. So what I'm going to do when you're rounding, start with the largest value in your number. Okay, so our largest value in our number is going to be the 2,000. Okay, so here's 2 significant figures. Okay, so that means I'm rounding to the hundreds place. Now, when I round to the hundreds place, I'm going to look and see, okay, is the number after it higher or lower than 5? So since this number is higher than 5, that's going to increase this number. So I'm going to get 2, 3, but I can't just put 23, right? Because 23 is different than 2,300. So what I'm going to do then for these last 2 numbers is I'm just going to put zeros, right? Because as long as I don't have a decimal place, any trailing zeros are not significant. So then my answer becomes 2,300 centimeters cubed. So now when you look at this example, They give us a lot of information, but they want to know what the density is. So the first thing I did was I wrote out the formula for density. Okay, density is mass over volume. And they want you to know, or they want you to find out the density of the gas. Okay, so they give me the mass of the container and the gas and the mass of just the container. So figure out how I got the mass of the gas. Okay, and then I do mass over volume. So I get this value. Okay, and again, I went out quite a ways because then I'll have to round. So I look at this top number, I have 2 significant figures. I look at this bottom number, I have 3, which means I need to round my answer to 2. And leading 0 is never significant, so these 2 don't count, so I'm going to go to after. 0.0013 gram per milliliter. You could also put it in scientific notation if you wanted, and say 1.3 times 10 to the negative third grams per milliliter. Okay, and that's the same thing.